All right, let's find some zeros. So we're going to use that possible list. Again, we're not going to always write it all out. We're just going to remember leading coefficient constant, 3 over 1. So since my leading term has a leading coefficient of 1, I will have all integer rational zeros in my list. So with this 3 here, it's either going to be 3, -3, 1, -1. So 4 possibilities. Wait a minute. This is a power of 5. That means I have at most 5 zeros. But my rational zero list has only 4 possible zeros. What's going on here? All right, so I need to graph this right away to get a picture of what's happening. So go to your calculator, enter it in, x to the 5th plus 3x to the 4th minus 10x cubed minus 22x squared minus 7x plus 3. One of the things I really liked about the old TI-83 Plus calculators is they had this wraparound feature so you could see everything you typed in. Now in the new 84s, the only thing I don't like about it is that it goes off the screen and they put the arrow there. And when you're done, the first half of your equation is missing. So the old 83 pluses were nice because you could see if everything was typed in correctly. The new 84s, once you're done, you have to hit the arrow and go back and check everything you typed in was good. So always take quick peeks up here to make sure you're typing it in correctly. All right, you should have it typed in by now. Again, biggest number 3, smallest number -3. Your Zoom 6 window from our last problem we did should be good. And here's my graph. Okay, wait a minute, hold it. If I couldn't go any further than -3, 1, 2, 3, what am I doing out here past -4? I mean, I can clearly see 1, 2, 3. There's a 0 at 3, 0. Type in a 3, I get a 0. -1, type it in, I get a 0. Wait a minute, take a closer look at that -1. We have a graph coming down, touching the -1, and turning and going right back up. So think back to when we were making those polynomial functions and our zeros had a multiplicity of 2. Remember, those were called touch and goes. So if you see a touch or go on the x-axis, you have a multiplicity of 2 there for -1. So we got to write down another -1. The graph is touching or crossing the x-axis 4 times with a 5th degree. We need at most 5 zeros. Where are these other 2? Right here. And again, they don't look like they're hitting the tick marks. Those would be fractional zeros. But we said we didn't have any fraction answers because your leading coefficient is a 1. So what are these other 2 zeros? What happens is these are now irrational numbers. Irrational numbers are numbers that cannot be written as a fraction, and therefore they don't show up in that possible list of rational numbers. So what we're going to have to do is find these rational, or I should say irrational zeros by factoring this down to a quadratic, and then use our solving techniques with quadratic equations to create and find our irrational numbers. So irrational numbers are something like a positive and negative radical 11 or square root of 11, or 2 plus or minus the square root of 5, something like that. So those are the numbers we're going to go find. So here's what we're going to do. We're going to take this polynomial, we're going to take our zeros, and we're going to do what I call piggyback synthetic division factoring. All right? So if you miss something, make sure you rewind the video and hear it again so you can understand how we do this technique. So I set up my synthetic division table. My 1, my 3, my negative 10, my negative 22, negative 7, 3. Take one of your zeros. Choose easy numbers first because we have a lot of multiplying to do. I'm going to take care of the negative ones first. Now, I know I'm putting in negative 1. I know the remainder must be a 0 when I get here to the end. If it's not a 0, you did some arithmetic wrong. Go fix it. So we bring down the 1. Take a deep breath, and you might be able to do this all at one time. Here we go. All right, negative 1 times 1 is negative 1, plus 3 is 2, times negative 1 is negative 2, minus 10 is negative 12, times negative 1 is positive 12, minus 22 is negative 10, times negative 1 is positive 10, minus 7 is 3, times negative 1 is negative 3, plus 3 is 0. Whew, we did it. All right, remember, negative 1, multiply these numbers up to the next column, add them coming down, just combine them. We have a 0. Now what we just did is we went from x to the 5th to an x to the 4th. So right now, my polynomial is x to the 4th plus 2x cubed minus 12x squared minus 10x plus 3. But don't rewrite it as a polynomial. We don't need that right now. We have more factors to do. So here is my piggyback synthetic division. Take this vertical bar, extend it down again. Put negative 1 in the lower left-hand corner again because we had these two to take care of. And again, when you work with this on notebook paper, you should always use 3 lines of your notebook paper. All right, so I extended it. We're going to run this through again. Again, deep breath. Bring down the 1. Negative 1 times 1 is negative 1, plus 2 is 1, times negative 1 is negative 1, minus 12 is negative 13, times negative 1 plus 13, minus 10 is 3, times negative 1 is minus 3, plus 3, 0. We know we get zeros at the end. It has to happen. Extend the vertical line down again. We have one more rational number to factor out. So now we're going to take care of the 3. So again, x to the 5th, x to the 4th, x to the 3rd. When we're done here, we'll have x squared, and we have a quadratic, and we can solve that. So bring down the 1. 3 times 1 is 3, plus 1 is 4. 3 times 4 is 12, minus 13 is negative 1. And it doesn't matter if you say negative 13 plus 12. Anytime I see a negative number, you probably heard me say, oh, it's that number minus that. My brain just works faster that way. 3 times negative 1 is negative 3, plus the 3 is 0. Now, what's left over is 1x squared plus 4x minus 1. That's my quadratic. We set it equal to 0. We solve it for x. This will not factor. I know it won't factor because the graph told me so. So now you either use the quadratic formula or you complete the square to solve it. Because it has a 1 in front of the x squared, completing the square is faster. So the minus 1 does not allow you to factor, so add it over to the right-hand side. Put in 2 blanks, 1 on each side. We're adding something special to each one. What is that going to be? It's going to be half of the b term. So half of positive 4 is positive 2. You square it to get a 4. Now remember, this is a perfect square trinomial. So the x and the plus 2 are going to go in your binomial squared, and 1 plus 4 is 5. Now, you can solve for x. You're 2 steps away. take the square root of both sides. That gives you plus or minus the square root of 5. Subtract over the 2. My other two irrational zeros as x-intercepts are -2 plus or minus the square root of 5. So there are all my zeros. Now, if you want to double check to make sure these two answers are correct, all you have to do is test one of them. So go back to your graph, and I'm going to type in -2 minus the square root of 5. That should be this 0 right here, because here's -2, and then minus takes me to the left right here. Now, remember, square roots are decimals that go on forever. So that will probably cause rounding errors. So I hit enter on my calculator, and sure enough, wait a minute, this is not a 0, but your cursor shows up on the x-axis. So remember, this went out to 12 decimal places. This right here is scientific notation from the calculator. This means 1.9 times 10 to the -11th power. That means move this decimal point 11 places to the left. Really? That's 0.1019. That's a 0. So anytime you see this E with a -11 or a -12, it's a 0. It's just a rounding error in the calculator. If you want, you can test -2 plus the square root of 5. That will land right here. But again, if one works with the plus or minus, the other one also has to work. All right, let's try another example. Again, we're going to have to graph this. There's no way to factor this by hand. So again, type this into your calculator. Hit graph, and your zoom 6 window is good because you have a constant of 8, a leading coefficient of 1, so your rational zeros should go from -8 to +8, so all your rational zeros are here. Again, as I look at my x-intercepts with a leading coefficient of 1, I should hit all my tick marks, but here I missed. Here I missed. Again, that means irrational zeros. And it looks like here is my 1. And it appears to me, so I type in a 1, it's a 0. But because it's in the shape of a cubic curve, let me back this up and get the cursor out of here so you can see it. Remember when I was talking to you about that multiplicity with the graph? See that flat line right there? And this is definitely going through the x-axis. That's a multiplicity of 3. That's the multiplicity of 3 right there. That little flat line that we saw. Now again, why does that have to happen? Because it's x to the 5th, and I need at most 5 zeros. So that means here's going to be 3, there would be 4, and there would be 5. So what we're going to do is we're going to use the existing 3 rational zeros, which are all 1s, to find and factor this down to a quadratic polynomial so we can find these 2 irrational zeros. So we're going to do the same thing as before. We're going to build that synthetic division table, piggyback style, but we're going to run 1 through all of them. So the 1, the -3, the -5, the 23, the -24, the 8. Put the 1 in and run it through the synthetic division table. I'm going to let you go first, and then I'll join you and we'll double check if your numbers are right. So if you want to pause it, pause. All right, welcome back. Here we go. Bring back down to 1. 1 times 1 is 1, -3, -2. 1 times negative 2 is negative 2, minus 5, negative 7. 1 times, you know what? I love multiplying by 1. All it does is move the number up to the next column. So when you get to that negative 7 and you're multiplying by 1s, just move it up to here right away. 23 minus 7 is 16. Move it up. Negative 24 plus 16 is negative 8. Move it up. 8 minus 8, 0. It has to be a 0. The calculator said so. Didn't you hear the calculator talk to us earlier? All right. Extend your table down. Run the 1 through again. Bring down the 1. Move it up. Negative 2 plus 1 is negative 1. Move it up. We don't have to multiply by 1 because it's not going to change anything. You love to have factors of 1 and negative 1. Negative 1, you just got to remember to change the sign. Move up the negative 1. Minus 7, negative 8. Move up the negative 8. 16 minus 8, 8. Move up the 8. Negative 8 plus 8, 0. That takes care of 2 ones. Let's do one more. Bring down the 1. Move it up. Oh, negative 1 plus 1, 0. Move up to 0. Negative 8. Negative 8 moves up. 8 minus 8, 0. Here's my quadratic. X squared, no x term, so there's a 0 in that place, minus 8. Well, I can solve that for x. Let's do that up here where we have more room. Add over the 8 to the other side. Take the square root of both sides. Now, what you're going to see in my math lab is they're going to say exact values, and we're finding the exact values. There's no decimals here, but they're going to want this radical simplified. So we got to simplify this square root. So since 4 is a factor of 8, and you can take the square root of 4, which is 2, that's like factoring the 2 out to the front. So technically you break this down to the square root of 4 times the square root of 2. Square root of 4 becomes 2 times the square root of 2. Here's my other 2 irrational zeros. Again, go to the calculator, type in negative 2. Notice this is not a minus sign. Minus signs are longer and in the middle, so be careful. Don't hit minus 2 square root of 2. You'll get a syntax error. It's negative 2 times the square root of 2. Hit enter, puts the cursor right there. Again, there's that goofy e to the negative 11 that shows up. Again, we're dealing with irrational numbers whose decimals go on forever, so we're always going to encounter a rounding error. So now we can find zeros that are irrational and rational through our calculator.